Alright, in this video I'm going to show you some advanced features and some also advanced setups with your Robo interface today. So first I want to show you how to connect multiple lamps to a single motor output. It's kind of a neat function in a different level that you have. So the first thing that we have to do is we need to change the level that we're in. So currently we're in level 1. And we're going to go ahead and move up to level 5 just for this. So in program elements, now you can see basic elements. You should have the same basic elements that we've had before. The only difference is this lamp output. And we're going to take a look at this one specifically. So if you notice, it's different than the motor output. So if I right click and change it to lamp, this has an on-off and reverse on action, where this one only has an on and an off. And I'm going to show you kind of the difference between this. This allows a greater expansion of the number of outputs you can have in your or on your interface. So let's take a look at the interface. I'm going to just drag this so you can see what we have here. Now if you have the old intelligent interface, these aren't labeled, but it's the exact same setup as the Robo interface here. So let me focus in on this. And these are kind of tough to see. But if you notice, under the M1 port, you should see an O1 and an O2. Those are your output ports. And if you notice, it goes from O1 all the way to O8 right there. There's O8. There's also another port on here you need to find. It is the common ground port that is on the interface, and it's over here on the left hand side, and it looks like an upside down T right there. This right here is what's called a common ground port. Now it's in a little different location on the old intelligent interface, and there are multiple ground ports on the Robo TX interface, the little black interface that is the newest version. But I want to show you how to hook it up so that you can actually wire multiple lamps, not necessarily together. They'll have independent function, but it basically you can put two lamps now in one M1 slot using that common ground port. So the first thing I want to do is I'm going to take a wire, and I'm going to use green as my ground. So I'm going to take one end of the green and plug it into the common ground port over here. And the other one, this is going to be now a hub where all of my ground wires are going to be connected to this plug right here. So I'm going to take another set of wires, and I'm going to plug in the red wire into the O1 port, and I'm going to plug the green wire into the common ground hub that I'm creating. And those just plug together. They have ports, they go together like so. The other end I'm now going to connect to my lamp. Okay, so again, one end of my connector is, or my wire is plugged into the lamp. The other end, I have one going into O1 and one going into the common ground port. I'm going to take another wire. I'm going to plug it into O2, and I'm going to plug this green into that hub that I'm creating. The other end of the wire, I'm going to plug the red and green into this lamp. So hopefully that makes sense. Again, I have a common ground hub that I'm creating where all of my ground wires are going to go into, and now I have a red wire going to this one and a red wire from O2 going to this one. And if you think about it, if this is ground, this would be 0 volts, and then if I apply 0 volts to this pin, there is no potential difference. And because of that, no current will flow and the lamp stays off. But if I put a 9 volt potential on this pin and a 0 volt here. Now I have a potential difference. Current's going to flow through the lamp and cause it to light up. And I can see this in the test interface window. So if I go back over here, expand this a little bit, and go to my test interface, it basically says that I can't have O1 and M1 both defined because they share the same port. And I click over here and I click on O1. So what I'm going to do now is give a high voltage to O1, and you notice that the lamp turns on. And if I give a high voltage to O2, the other lamp turns on. So I can turn them on now independently and turn them off independently from each other using a single M1 port over here. Kind of cool. So now it expands from 4 outputs to 8 outputs that you can drive. And this doesn't just work for lamps, it also works for motors. You can have motors that, if they only spin in a single direction, you can wire them up the same exact way. The only time you need to use both a green and red in a M port is when you need reversibility. So for example, if you have a motor that spins one direction and needs to spin the other direction as well, then you have to plug both the red and green into like an M2 port, for example. Okay, I'm going to do a little program next on this. Okay, so I'm going to close this out, and I'm going to write a pretty basic program here for you just to show you what and how these are used. So I'm going to pull in a couple of these, and basically I'm just going to make these lamps blink back and forth. So pretty simple. A couple wait functions. Start boy. And I can right click. O2, I'm going to turn this one off. And on this one I'm going to turn O1 off. And turn O2. Change the times. Okay, so here we go. Let's run this and see what it looks like over here. So you can see now that we can control the lamps independently from each other. They're blinking back and forth, and the next thing that we can do is we can add a display. I think this is one of the most important things that you can do with your programs, is be able to add displays so you can see what's going on. So I'm going to display the value of AX. So I have an AX sensor, say photocell, so I can right click and change the image to photoresistor. And I'm going to then put that into what's called a panel display. And then I need to go into operating elements and grab a display. Now there's a variety of displays. I'm just going to use a text display to display this. I'm going to right click. I'm going to change its name to AX so I know what it is. Okay, so now I can change what's in the text. For example, let's say this is a marble color reading. So we can say marble reading and then equals whatever it is. And then here we might need to expand this to like 20 digits per column to make it a little bit bigger, so we can get our marble reading in here. Once we've assigned our display, we now need to tell it what panel display to record to. So I'm going to right click on it and click on AX. That's what we named that display. So now when I run my program, you'll notice that it gives me the marble reading, and if I cover up that sensor, you'll see that that marble reading will change depending on that light sensor. This is very handy if your students are programming and they kind of want to know what's going on with their sensor and what the value is. This will then give them a value so they can test and make sure that the conditions are right. Also, it kind of stresses the importance of making sure that your sensors are shielded from ambient light. If I were to draw the curtains in my classroom here, you'll notice that the curtains are drawn and that my hand's still not over the sensor, and the value went up to 450 roughly from 180. So those things are important for them to be aware of when they're designing their structures. Okay, so I'm going to add another element here. I'm going to add a button. This is going to be a software button rather than a hardware button to make changes on my system here. So if I go to control elements, you have these different sliders which can act as analog inputs, and then you have these buttons as well. So I'm going to add a button. I'm going to change its name. This is going to then, whenever I push the button, I want it to then activate this code here while that button is pressed. So I'm going to go in and I'm going to make a few edits here. If I go into branch, there's now a branch option with a data input. And this is rather handy because now I can use a variable of any type to go into this data spot A, and then I can use some equation here to then decide if it's going to move on or not. So I'm going to then go into inputs, and I'm going to go into panel input and put this guy right here. I'm going to right click, and now I'm going to connect that to this button. And then I'm going to change this so that the value is equal to 1. So now if you look, it says flasher now becomes variable A. So when flasher is not pressed, it's 0. So is 0 equal to 1? The answer is no. It's going to loop back and recheck. When the flasher button is pressed, it's then going to start flashing the lights, and I'm just going to bring this back up to the top. And let's see this work, and I'll pull this across so you can see the actual hardware as it's running. So again, it's not on. I click on the flasher button and it starts flashing as soon as I let up. And you're saying, well, why does it do that? Why does this stay on? Well, if you look at the last option that I have, when this blinks, O2 is still on when it kicks out of the loop. So really, to change the code and make this better, I would need to then add something here if it's not. So if it's not pressed, then I should have both lamps turn off. So those are things that I like to have my students do, and then encourage them, okay, what can we do to make this program better and more like what we want. Okay, so I'm going to make one additional video with a few other things that are in here and show you where some example programs are located. So we'll end this video and then look for the Advanced 2 video as well.